Hi everyone! Today I'm going to talk about how to use the digital control of Solo and how can you send the commands or receiving the feedbacks to Solo using UART or USB port and the data packaging that you might have seen on our website. So a lot of people asked us to make some sort of tutorial for that, and I'm going to here explain you a little bit more how you can utilize these features and how can you control Solo completely with UART or USB in completely digital mode using data packets. So as I said before, there are two ways of accessing the digital control in Solo. You can access it through UART port and you can access it through USB port on the Solo, which will turn into a COM port in your PC. And you can get connected to these inputs and send your digital commands to Solo. If you use UART mode, the hardware setting for this particular communication is mentioned here. There is the exact baud rate, which is 937500 bits per second, and the other one is the standard baud rate, which is the baud rate that you might find on PCs or on modules that they don't support the exact baud rate of Solo, and in both of these baud rates you can work and send and receive the commands from Solo. If you use the USB port, on the other hand, you don't need actually to have the exact baud rate. You can use any baud rate in between 937500 bits per second to 9600 bits per second. How things work actually in digital control of Solo. So first of all, you use USB or UART to apply any type of control that we did before using analog port. We normally send the data packets, which are used both for commanding and getting feedbacks from Solo. And in order to write or read something from Solo, in any case, you need to send a packet to Solo. So either you set something, so you need to send a packet, or you request for reading something. So in either of the cases, you need to send a packet. Now I'm going to talk about how to actually form a packet, how to create a packet to send, or how to interpret a packet that comes back from Solo. But before that, you need to know all the packets we're talking about with Solo are having 10 bytes of size, fixed. So it doesn't matter if you're sending a command or you're receiving a feedback, it will be 10 bytes in any case. And all of the numbers are presented here and also in the packet in hex format. A data packet of Solo is composed out of 6 different sections, as you can see here. The first section is the initiator section, which is a constant 2-byte value, FFFF, as the packet initiator. So it defines just the packet has been started and it's acting like a header for the packet. Then we're going to have the device address, which is the address of each Solo that you're going to talk or you're going to set something on it. And you can give a completely unique address to a Solo that will define the address of the Solo for you. The next thing is the command code, and in this part, which is 1 byte, we define what type of command we are sending to Solo or what type of feedback we're asking from Solo to send us back. So each command has a unique code in between 0 to 155. Next section is a 4 bytes sized part, which contains the data section. So if your packet should tell or should set a value inside Solo, the data part should reside here. Also the feedbacks you read from Solo, the value of the feedback or the parameter that you are reading is stored in this section of the packet. There is a CRC byte here, which is not used in beta models, just for redundancy check. And the last byte is the constant value of FE, which defines the ending of the packet. So combining all these two together, you can make a packet to send, or you can interpret a packet that's coming back from Solo. After knowing about the packet, we need to talk a little bit about the data part of the packet. You saw in the previous slide that this part, the data part, is the part that contains the values that we want to send or the feedbacks we read from Solo. But the data type of these numbers is not actually identical. Depending on the command code and the nature of the feedback or the command you're sending, you might use one of the following data types. You might use the unsigned integer value with 32 bits, which is used for positive integer numbers. You might use the fixed point data type with 32 bits, structured as 1 signed bit, 14 integer bits, and 17 floating point bits, which actually are used to represent the floating point data types. Because in a computer or in a hardware, at the end of the day, everything should be stored in forms of bytes and bits. So we don't have a float number in a real hardware. We have to replicate it somehow, and fixed point data types are one of the ways that you can approach that problem. There are other types of data types like IEEE 754 that is used in other systems, but here in Solo we use fixed point data types. And the last data type is integer values, signed integer values with 32 bits, which are used for positive and negative integer numbers. And when you are working with Solo, all of these numbers, finally, they should get into hex format to be sent or to be read from Solo. And to know more about how to convert these numbers from hex values to the real values or vice versa, you should read our user manual. We are talking deeply about how to do these kind of conversions and how to go from a real world value to one of these. You might ask, okay, how can I know the data type part? How can I know how to form a packet? And here I'm gonna show you an example, a practical example of forming a data packet for a specific type of action that we're gonna do. But before that, I'd like to show you a snapshot from the right command table that you can find in the user manual. And I'm gonna explain you the functionality of each of these sections. The first section that you see in that table is the command name, which is just an explanation of the type of the action that the command or this particular command code will do. The next section is what you should put in the device address if you use this specific command. So normally we put the same device address as the Solo that we're going to talk to. The next thing is the command code, and this defines the unique ID for each command that we're going to use. So if you want to set the address of something, set the address of Solo, you need to use the command code of 1. If you want to change the command mode selection, if you want to set the current limit or the torque reference, you need to use one of these command codes which are unique and doing only one action at a time. The data type here defines for you that if you use a specific command code or if you read a command from Solo that has this code in the command code section, what is the data type of that command? Okay, what is the data type of that packet actually? And here you can see that the data type of the device address will be unsigned integer 32-bit, but the data type of the torque reference IQ here, as an example, is fixed point 3217. The next part defines for you the acceptable range of the data that you can put in the data section. So if you want to form a valid packet, you need to put an acceptable data and within this range inside the data part. So if you want to set a device address, you need to put inside the data section the device address something between 0 to 154. If you don't do that, Solo will not accept the packet and it will send you back an error command. The next part is the description of these commands a little bit more, and the next part, which is a little bit important, is telling you that where the results will be stored. So if you set a command, if you send a command like to set the device address of Solo or select the command mode type, where the final result will be stored. So we have two different storage. We have the long-term memory, which will not be affected by power recycling or turning on or turning off of Solo. It will reside there almost forever as long as you don't change it, which are shown with M, and they're standing for long-term memory parameters. And we have also the volatile memory that after power recycle they will be forgotten. So normally we store the parameters that are not changed regularly into the long-term memory. And for example, the device address is something that we don't change it every time. So that's why it stays in the memory. But something like the reference of the current or the torque reference is something that you want to change it in real time, or you want to change it to control a motor. So that's why it stays in volatile part. And the last part is the default value of these parameters, which means that when you receive Solo for the first time from the factory, or if you do the reset factory, the values that will be stored in these sections by default are these numbers. For example, as you see, the current limit value by default is set at 32 amps. You can change it and it will be stored in the memory. It will be there forever as long as you don't change it again. And the default value for that is 32 amps. Okay, I'm going to show you now an example of how to set the device address of an imaginary Solo, which is having the device address of 0 to 1, and how to form a packet to say this to Solo. And we're going to go like this. We're going to first fill the fixed part, which is starting with the initiator part. It has a fixed value of FFFF. So we're going to put it there. This is a portion of our packet. The next part is the device address. I'm going to fill that. Now my device address is 0. So I put 0 here. I'm going to talk to a Solo with device address of 0. By looking at the right command table, I see that if I'm going to change or set the device address, my command code is 1. So I put 1 here in a form of a byte in hex format. And the next section, which is the data part, is the value that I'm going to set in Solo. And my data type in this type of command, based on the command code I have here, is unsigned 32. So 1 in that format becomes like this. You need to convert the 1 from decimal representation into unsigned in 32, which is not changing anything. And then you need to convert it back to the hex. So the hex, the 32 bits hex part of this data part becomes this format. The next part is putting a value in CRC, which is not used in beta model, so I put 0 here. And the last part is the ending bar. Now we've learned how to send a packet to Solo. But what happens after you send a packet to Solo? Basically, there are three main scenarios that can happen. The first case is when you're writing a parameter into Solo, you're changing a value. So in that case, if you correctly form a packet, Solo will echo back the same exact packet that it received. As an instance, if I send a packet to set the number of poles of a brushless motor on 4 as an example, on a Solo with address of 0, I have to form such a packet, this one. If I send this packet to Solo, after a while, after a very short time, I'm going to receive back this packet, which is like an acknowledgement. Is exactly the same packet we sent, but this time it comes back from Solo to you. So it shows that Solo received it. It was well in the range. It was an acceptable packet, and Solo applied it to the parameter that you asked for it. The next case can happen is in a case of reading a parameter. Again here, if you correctly form a packet and you send it, Solo will send you back the requested value with the same command code. And the last case is in case of an error, and it happens when you send inside the data section a value out of range. In that case, Solo will respond back with an error message. The error message is formed like this. It will have the exact same 10 bytes with the initiator and ending, the CRC 0, the same device address, the command code you send, but in the data section you're going to receive this value, 8 E's, which stands for error. Now we're going to learn how to read a packet from Solo. So to read a feedback or something that you're interested to know the value from Solo, first of all, we send a write packet to request the read. And then we keep listening to the port to receive the packet that we asked or the errors that might happen. To simplify this, we have prepared a very simplified automata in which we're going to explain you how to receive data safely from Solo. So you have two ways. You can keep monitoring the line of receiving, or you can ask something from Solo to it, so it sends you back the parameter. Once the valid packet received from Solo, you need to extract the command code to see what type of command you're reading. And based off that command code, after you extracted it, you decide how to convert the data section. And after you converted the data section properly, you can use the value. And again, the process restarts. I'm going to show you an example here about this. I'm going to show you how, for example, if I like to read the voltage of phase A of a three-phase motor from a Solo with the address of 0, what should I do? Again, you have to look at the read command table. In the read command table, we have this. We have, in order to read VA, the command code is 0x82, is 82 in hex format. And the data section should be 8 zeros in hex format. But the data you're going to receive in that case will be in fixed point format. So I'm going to form a packet to read that. What should I do? I should put the same initiator, the ending and the CRC, these are fixed values. My device address is 0 because I'm reading from Solo with address of 0. The command code is 082, the same as here. And now the data, because I'm asking to read this value, doesn't matter, just put 0. And then this is what's going to happen. So the final packet we're going to send is this. It has a shape like that. Only the command code and everything else is 0. We have the fixed parts here and here, also the CRC. And once you send that packet, you're going to receive such an answer. We send this packet, we receive this packet. And the packet below has exactly the same command code, has exactly the same device address, but the data part is different. You see, this is the data part. And that's actually the exact same value of voltage of phase A at the moment that you requested it. And here, based on the fact that this data section is from the fixed point 3217 data type, after the conversion of the data part into the float value, actually this is what we're gonna get. This is the value. 23.98 volt is what we read for phase A voltage. There is another interesting capability of Solo. It's called monitoring mode with the command code of 0x19. If you send this command code to Solo, it will continuously send you some critical parameters, with each of them having the sampling frequency of 1.17 kilohertz. And they are all sampled at the same time. So to activate monitoring mode, again, you can form a packet like that. If you put 1 in data section with the command code of 19, it means that you want to activate the monitoring mode. And if you want to stop the monitoring mode, you're going to put, instead of 1, you're going to put 0 here. And that's going to stop the monitoring mode. Once you activate the monitoring mode, you're going to receive 10 different values, 10 different parameters all the time with the sampling frequency of 1.17 kilohertz for each of them. And this means that you're going to receive the voltage of phase A, voltage of phase B, and the voltage of phase C can be derived with some of these two parameters. the current of phase A, the current of phase B, and the current of phase C is again sum of these two parameters. You're going to receive the power supply voltage, you're going to receive the DC motor current, you're going to receive the DC motor voltage, you're going to receive the quadrature current, which is actually the current that acts in torque generation in three-phase motors like brushless motors, permanent magnet synchronous motors, and AC induction motors. And you're going to receive ID, which is the direct current in three-phase motors. And in special case of AC induction motors, it's called the magnetizing current. And finally, you're going to receive the speed measured or estimated by Solo, both in sensorless and sensor-based methods. We use monitoring mode in cases that you want to keep monitoring these critical parameters all the time during the motion, during the movement, and it's going to be really helpful for you. The last thing is the error register. There is an error register with the command code of 0xA1 that once you receive this command code, it means that you're receiving the error register. The error register is a 32-bit register, and each bit of that has a meaning for itself. For example, the bit number 0 is dedicated for overcurrent, bit number 1 is dedicated for overvoltage, bit number 2 is for over temperature, and bit 3 to 31 for now are set on 0. Once an error happens, Solo will keep reporting the error continuously on the UART and USB line. So, regardless of what type of controller you are using, you will receive this error and you can decide what to do next. You can decide to stop the whole system and find the cause of the error, or you can decide to overwrite these errors. And overwriting them means you're going to tell to Solo, okay, go on, ignore the error. Solo will ignore the error for a short time, and if the error occurs again, it's going to go back to the same step and it's going to stop your motor. You have to do again the overwriting and so on, because these errors here are catastrophic errors. They cannot be ignored for a long time, and if they persist to occur, it means that there is somewhere some error. So to avoid damaging Solo, it will anyways stop and asks you to overwrite it or check the cause of the error. Now I'm going to show you at the end of this tutorial how to use our motion terminal, which is named Solo Motion Terminal. You can access this software through our website. It's a web-based software. This software is made to enable the users to access and control Solo in a cross-platform manner using the browsers, using the web browsers. And here I'm using Google Chrome as an instance, and I'm gonna show you how this software can send and receive some packets from Solo. And the very first thing you need to do is, first you need to make sure that in your browser the serial API is enabled. In Google Chrome, for instance, if you insert this command, which I've inserted on top, you can make sure that this experimental web platform feature is enabled. This will enable your browser to be able to communicate through COM port to Solo. Once you're sure that that's kind of enabled, by clicking on this plug thing, you can select the COM port of Solo, and once you press connect, it gets connected. This one gets green, and then it means that okay, you're connected to Solo. There is a sample packet here that you can send just to make sure everything is fine. If you send that packet, you're going to receive an answer. This is the packet received subsequently due to this packet that we sent. And if you click on this, here on the conversion table, it will do for you all the conversions possible. This packet actually we sent reads the voltage of the bus or voltage of the battery. And the answer is what Solo is reading. And you can see that here, because I know this 86, the packet command code 86 has the fixed point data type, and after conversion into floating point, this is the valid conversion. So it's telling me that the voltage of the bus supply in my system is 52.6 volts, which is exactly true. You can use this for any other types of commands. You can send any other types of command. For example, I reduce the bus voltage to 50 volt almost. I send again. I click here, it's 50. You see, it's reduced. So this is a simple interface to send and receive all the possible commands. In future, we're going to add the actions and monitor part for our users to be able to send the commands without sending the packets, and then finally monitoring and logging all the data. Thank you so much.